Hey, we're going to look at star colors now. We know that stars come in a lot of different colors depending on what their temperature is. So some stars can be red, they can be yellow, they can be blue, and a lot of them appear to be white when you look at them in the sky because they're too dim for us to really register the color with our eyes. And if it's a really hot star, like up to maybe 25,000 kelvins, then that one will appear a little bit blue because it's brighter in the blue end of the spectrum. And if it's a really dim star, or I should say dim, but a colder star, cooler star, temperature around 3,000, then that will appear redder because you can see there's more emission in the red end of the spectrum. And if it's in between, then it may appear white. If it's like 10,000 kelvins, if it's 6,000 kelvins, it would be probably around here. And that would be probably in the yellow part of the spectrum. It kind of looks kind of yellowish, like our sun. So the color is often expressed as something called the color index. And what we do is we measure the brightness at different particular wavelengths using different filters. And so by clicking on this tab, we can see what some of the filters are that people can use. There's one called a U filter, and that is the ultraviolet filter. And you can see that actually only allows light to come through if it's in the ultraviolet range. And then there's a B filter, that's a blue filter. And so that allows blue light to come through, and you can see the range that that one has here. And then there's something called a visual filter, and that lets in light in the middle of the visual range right there. And then there's a red filter, and that lets light through in the red end of the spectrum. So what you do is then you can measure the magnitude of a star at these different wavelengths, and then you can subtract one magnitude from another. Probably the most common one is going to be the blue minus visual. And so what you can do then in this little simulator is to change the temperature, and you'll see how that affects the B minus V color index. So if we pick a star that's very bright, like let's put it up to about 25,000, this is very high, then you'll see that it's emitting a lot more in the blue part of the spectrum than in the visual part of the spectrum. So it's brighter here than it is here, meaning that the B number is going to be a lower number, okay? And the V number is going to be a higher number. And so we're subtracting the visual number from the blue number. And so you end up with a pretty small number. So the bluest stars would have B minus V color indices of around minus 0.4, about minus 0.4. On the other end of the scale, if you have one that is really red, goes way to the other end, then it might get up to somewhere around 1.65. And that's the highest this one goes. It goes down to about 3,000 kelvins. And you can see for this star, the visual magnitude is about 9.39, and the blue magnitude is about 11.04, meaning it's brighter in the visual than it is in the blue. And then we're subtracting the visual number from the blue number, and we get a number that's about 1.65. So that is a pretty red colored star. The reason why you would use this is that in the older days that you would be able to pretty easily measure these values. You would just have a photometer, a device that you would hook up to your telescope, and then you would pop in these different filters and just measure the magnitude of a star in the blue range, and then take that filter out, put in the visual filter, measure its magnitude, and then subtract those two numbers. And you had a pretty good indication of what the temperature would be. So it's kind of a stand-in for temperature and some other things in some of the measurements that we're going to be talking about. So that's color index. Thank you.